Hi, my name is Leo Edwards. I am here today to discuss my second challenge assessment. The assessment is about real-world situations and using our mind to think of solutions. The picture in front of you is a wall. This wall is made of two steel rods, and in the center there is insulation, and on the outside there are two steel plates. In the following presentation, I will change three parameters, solve the problem, and change the insulation, and I will talk about some real-world changes that could happen. Here is the original problem solved. As you can see, I drew a resistance network that has 3 in parallel that you solve for, and then 3 in series that you solve for. The results that I got were that the heat transfer was 486.27 watts. The resistance was 1.086 kilowatts. I decided to plot a temperature versus position of the wall so that you could see at each point in the wall what the temperature was. I listed the temperatures. T1 was 0, T4 was 22 degrees Celsius. I knew this was the temperature difference, so I calculated that. T2 and T3 value. As you can see, it doesn't make a big difference. So, for some background, what is going on? Nowadays there's a crisis on not having affordable heat for your home. We want to lower the cost of electricity by keeping heat in our homes. The IEA says to improve your insulation, you want to keep your heat in. This will help lower the cost of electricity. So what am I looking for in this problem? I want a lower heat transfer, a high resistance, and one of the cheaper options. This is what I will explore for the parameter changes. This is where I explored the insulation. I changed the insulation to concrete. Some schools are made of concrete or they have bricks. For the concrete, I got a super high heat transfer of 4,723 watts and a resistance of 0.112. Seeing this result, you have to think this is not very practical and it should not be used. I also plotted temperature versus position. You can see that this varies from the original problem. Some other options that might be better, and definitely would be better than concrete, would be fiberglass insulation. This is going to be the most cost-effective insulation for keeping our heat in. It may not be great for the environment, but it works. This is where I changed 3 parameters in the experiment. Parameter 1 was me changing the area of the insulation. As you can see, I plotted heat transfer versus area. As I changed the area, it did not affect the heat transfer too much because the steel bars just ended up taking away some of the heat transfer or increasing it. I would not recommend this. Parameter 2 was thermal conductivity of the material. As you can see here, this was linear and this was a big effect. As thermal conductivity increased, so did the heat transfer. I would say that having a lower thermal conductivity in your home is going to help keep heat in. Parameter 3 was the temperature difference. I decided to increase the temperature difference from 22 all the way up. And as you can see, as I increase the temperature difference from 40, the heat transfer goes up. This makes sense. So, if in your home you have a high temperature difference compared to the outside, you're going to lose more heat. Some improvements other than just insulation could be windows. Double-pane windows are great. Double-pane windows have many benefits. This could mean that they have a greater thermal resistance network. Some drawbacks would be that they are expensive and they can be hard to install. But the more resistance, the better. Quad windows offers a window with 4 panes in it, only improving. They say that this helps improve your thermal insulation and just keeping heat in your house. So what does improving the insulation do in our case? So improving the insulation helps keep heat in your home and save money. There are many ways you can do this. Some of the benefits of improving your own insulation are do-it-yourself installations. Blanket bats can be made from natural fibers. As I said before, I listed fiberglass, but this is also a very good alternative. Some drawbacks to this could be that you might need special tools, or you might need to hire a contractor, depending on the installation. Spray foam installation would be one of those, and you could also install it wrong. After working through this experiment, I decided that blanket bat insulation would be the best, as a high resistance network and a low heat transfer. I think this is the best solution. Here are my sources.